Having me. It's a pleasure to be here. I'm sorry that I cannot be there physically. I always love to visit Philadelphia. But anyway, let's do this virtually and see how it goes. I was actually telling Ben before that I feel that these days I'm spending my life in an endless Zoom meeting, but I guess that this will be a more fun than a regular Zoom meeting. Anyway, so I'm going to share my screen. And originally, let me see, share a screen. Originally, I was planning to talk about the book, talk about how chats lie, but this bores me to tears already. Because if you want to, if you want to learn about the book, you can take a look at the book, and that's it, right? And later on, I will share a few links with you related to the book. For example, the clarifications and some corrections, because no book is ever perfect. So I thought that instead of talking about the book, although the talk will include a few parts that are related to the book, that provides content that comes directly from the book, I'm going to do something slightly different. I am going to talk a little bit about what I'm doing now and what I'm thinking about right now. So the title of the talk actually is not going to be Not How Chats Lie. It's going to be Reasoning for Data Visualization, how to make choices when we design visualization. Because this is what I'm thinking about right now towards future writings that I'm going to mention in just 1 minute. So before I begin, by the way, the background image that you have in there is a screenshot from a great visualization project by Nadi Bremer, titled Why Do Cats and Dogs? It's a project that I art directed myself and Nadi created. It's a fun project containing tons of cute illustrations of cats and dogs moving around. And what the project visualizes is tons of Google data of what people search for when they search for, why is my cat doing this weird thing, right? So it basically visualizes the most common searches for why is my cat doing this or why my dog is doing that. And the results are actually quite surprising and a little bit, quite funny if you have a pet at home. Anyway, just giving Nari a little bit of credit for the beautiful image that I'm using as background for many of these slides. Anyway, so yeah, the books. All right, so yeah, sure. I mean, I have How Chats Lie, the previous book, The Truthful Art. So I am already working on a new book. The contract is not signed yet, but it's a done deal. So I think that it is safe to announce it. In the fall of 2021, next year, my next book is going to appear. It's the first book that I'm going to co-write. It's a book that I'm co-writing with Alisa Fowers, who is currently working at the Washington Post. Alisa is both a statistician and a designer, and one of my students at the University of Miami. And I'm going to co-write a book title, for now at least, The Art of Insight, How Great Visualization Designers Think. And it's going to appear through Wiley Publishing in 2021. So this is a done deal. So expect that. So what I would like to do today is so to give you sort of like an overview or a heads up to the thinking that I'm having these days that will probably lead to something that will appear in the book itself. It's like what the book is really about. The book is basically going to be a tool that I think that anybody can use to make good choices whenever we design visualizations. And before I proceed, I would like to sort of like frame what types of visualization I'm talking about. I'm not talking about visualization for exploration, exploratory data visualizations. I'm talking about explanatory data visualizations, the kinds of graphics that I design as a journalist, right? So the book begins with something that I already wrote about in How Chats Lie. The whole premise of How Chats Lie is that a visualization is not just an image. A visualization is an argument, and it should be treated the same way or in a similar way that we treat text. Okay, so it's something that needs to be read in order to be understood. Therefore, and this is a consequence that I don't describe in How Chats Lie, but it's going to be one of the core ideas of the Art of Insight, is that visualizations cannot be just designed based on our own personal preferences, although that's a factor, right? If you have experience in visualization and you say, I think that I prefer this rather than that, that's a good reason because you have some prior experience that may guide that decision. But that should not be the only reason to do something in data visualization. You need to have reasoned and justified choices. You need to be able to sort of like to speak to yourself and speak to others to describe why you did something the way that you did it, right? Also, another consequence of this thinking is that visualization is also similar to reading and writing in the sense that it cannot be based on strict rules, like do this, don't do that, right? The way that we make decisions in visualization is much more flexible. We begin with a grammar, with a symbol systems and a grammar in the same way that when we write. But then after that, there's a lot of leeway, right? There's a lot of space in which you can navigate through certain constraints and limitations. As long as you stay in that area, you can move to the left or to the right or forward or backward. There's sort of like a virtual space of decision making in which 2 or 3 different visualizations may accomplish the exact same goal. I would like, for example, that people will stop talking about visualizations as if it were a set of rules that are set in stone, and start talking a little bit more about reasons, how we reason in the decision-making process that may lead to designing a great visualization. So part of the thinking in the book doesn't come from other visualization books. It's a book that will also talk about a lot about ethics and moral reasoning. One of the things that I've been interested in throughout the years is the literature in philosophy, and in particular, moral reasoning. And one of my favorite authors in this field is Derek Parfit, who has a wonderful book titled On What Matters, which is widely considered one of the main books on philosophical ethics in the past century. And he defines reasons. A reason is basically something, right? A fact or a series of facts that you use that count towards you making a decision, or to have a belief, or to have a desire, or to act in a certain way. And reasons come in different varieties, right? Conventions are reasons. Personal preferences are reasons. Empirical evidence is a reason as well. So we have different reasons that we can weigh whenever we are going to make a decision about visualization. It is also possible, by the way, and this is something that I want to write deeply about in the book, to create a hierarchy of reasons. So for instance, right now, I think that, for instance, personal preferences are at the bottom. Then on top of that, conventions and sort of like rules, all right, should have a bigger weight than personal preferences, or we can weigh them next to each other. Empirical evidence is on top of that. So we can create sort of like a hierarchy of reasons. So when you have several reasons, you can put them sort of like in the balance next to each other, and that may lead you to, to make the choice. Now, the reason why I think that this is the right framework to think about visualization decision making is that I have changed my mind about many things, many rules of visualization throughout the years. I'm not going to give you just an example of the thing that I would like to write about. This is probably an example that will end up in the book in one way or another. How many times have you heard or have you read people saying pie charts are bad, don't use pie charts? Or bar charts should start at 0. Well, that's not true. Pie charts may have their uses in certain cases. All right, that's one of the things that I have changed my mind on that happened many years ago. But for example, let's take another one. Bar chart should always start at 0. That's something that I have written myself, right? That's a recommendation that I have given and that I still give. But I'm going to tell you why I still give that recommendation in just 1 minute. All right, so how can we reason about this? Should bar charts start at 0 or should not start at 0, right? So the way that I will reason is, right, it's like this to say, I've written these myself, or don't do that, right? Never do that. That's really, really bad. That's really, really bad, right? That's truncating the y-axis of a paragraph, right? But at the same time, I also explain in some of my books that that is not necessarily bad. So doing the same thing with a line chart, that's not necessarily bad. And the reason why I wrote about this before is that I assumed that when a person reads a paragraph, we focus on the height of the bar in order to estimate the sizes of the bar. But when we read a line chart, sort of like the visual cue that we use to read the line chart is different, is the relative position of the dots. Therefore, not having a 0 baseline in a line chart may not be as bad as not having a baseline, a 0 baseline in a bar graph, right? So that has been my reasoning for many, many years. However, we need to ask ourselves, do readers focus on the height of the bar when reading a bar chart, right? In which case, never truncate a 0 baseline, never take away the 0 baseline, right? Or do they focus more on the upper edge of the bars? Because if they do that, right, then the bar chart is actually not better or worse than the line chart, right? Because what they are actually comparing is the regular position, the relative position of those two objects, not the mass of the object itself, in order to estimate the sizes. So if that were the case, that will change my mind. It will be a reason to change my advice. Now, I still, this is a note and a side note that I make here, I still advise to have bar graphs with zero baselines, but it's not because of an empirical reason. It is something that is based on sort of like the logic of the grammar of graphics. A bar graph, when you design it, you're using height or length to represent the data. Therefore, as a consequence of that, right, I think that it's still advisable that the height or the length of the bar are proportional to the data that we have, just because the encoding itself is height or length. Now, the reason why I have changed my mind about all these issues, or I'm still thinking and my opinion about all these issues is evolving, is that I pay attention to the literature, the empirical results of experiments that are being conducted. And just today, just an hour ago, there was a discussion about a paper that just came out, is going to be published soon, that discusses all these issues, that compares how people, estimate the relative positions and the relative sizes of all these objects. And there's really not a huge difference between truncating the axis of a bar graph and truncating the axis of a line chart. Both of them can show the data correctly, or both can be equally misleading. I still advise, again, not to truncate the axis of the bar graph, but again, not because of empirical evidence, but because just of logic, the logic of the grammar of graphics. The encoding is height, therefore make height proportional to the data, right? Which is a completely different reason. It's not an empirical reason, it's a logical reason. So this is the kind of writing that I would like to have in the next book. It's like, through examples of this kind of reasoning, I would like to instill in readers the sense that if we want to reach good decisions in terms of designing a visualization, applying rules that are set in stone is sort of like a path that will lead us nowhere. What we need to have is to have conversations in which we provide each other with reasons and we discuss with each other. Sometimes these conversations can happen with yourself, right? Your reason with yourself. Sometimes, more often than not, will happen with other people. So what kinds of questions I would like to discuss? And this is just a preliminary list of things, a preliminary list of questions that I think that we all need to pose to ourselves whenever we are about to put a visualization out in the world to explain something, right? Why to visualize, what to visualize, how to visualize this, who to visualize it for, et cetera, and so on and so forth. So I'm going to just go over them very, very quickly, all right, to keep this talk in under 50 minutes or so. So the first question, right, and this is a very important question, it's actually related to what Ben said before about coronavirus, is why should my visualization exist? How does my visualization contribute to the betterment of society or to the more understanding, right? Or I am just doing it, just out of whim because I want to do it, right? Now, in the book, I would like to explain that the way that I think about these issues is that I have sort of like in my mind two big groups of visualizations, right? One type of visualization, I call them why not visualizations, right? And why not visualizations are visualizations about inconsequential topics. Why do cats and dogs? Well, that's fun, right? That doesn't have an impact on people's lives. Well, life or death, right? It's like, it's fun and funny, it's entertaining, it's inconsequential. I would call that a why not? Why not visualization? Why shouldn't we do this? It's fun, right? Let's devote some time, it's entertaining, right? We will have fun, right? That's a why not visualization. But there are other types of visualizations that we could call why visualizations. Why should these exist, right? So let me show you just an example. It's probably going to be one of the examples that are going to open the new book. Now, years ago, there was a shooting in Connecticut, very famous, in which a lot of children were killed in a school, right? And in Sandy Hook, the name of the school was Sandy Hook Elementary School. 20 or 20-something children were killed in this event. It was a terrible event. A day or two after, a newspaper in New York called sorry, I'm not seeing my own screen over here, the Journal News in upstate New York, they published this map. This map is not available anymore online. There are only screenshots right now because it was withdrawn from the internet. It's a map that showed the positions of people in New York, in the state of New York, who had or who have a gun permits, right? Who hold a gun permit, a handgun permit, all right? So this locates the sort of like the addresses of all these people, right? So when this came out, when this map was published right after the shooting, a lot of people started complaining to the New York Daily News. Why are you disclosing all this information? Why is all this information relevant, right? They disclosed, gun permits for pistols, revolver permits, not long guns. This was only handguns, and only for these two counties because they couldn't get data for other counties. The publisher of the newspaper said, well, we felt that sharing this information about gun permits in our area was important in the aftermath of Newtown shootings, that our readers should know about, who may have a gun around them, right? But these may have tons of different consequences, right? Publishing this type of information in the form of a map. So this is one of the examples that I think that I would use. Again, by the way, I'm not saying that this is necessarily wrong. I have my own opinions about this map that I will probably disclose in the book, but I would like to use this as an example to pose this question: the importance of asking ourselves whenever we are going to design anything, to ask ourselves, why? Why should this information be made public? Who benefits from getting this information, and who may get hurt from publishing this information, from putting this information out? Because whether you are in favor or against the Second Amendment and guns or whatever, the fact is that all these gun owners are legal gun owners. They have a permit, they can have guns. That's the law of the country. And they may get hurt by the fact that the position of their houses or their homes is basically displayed on a map. And you need to weigh that, right? You need to weigh the potential consequences in your decisions. In the literature about ethical thinking, right, there are different schools in ethical thinking. We have deontology, for example, which thinks about how you should act, right? We have also virtue ethics, which is that people who are virtuous tend to act better. Therefore, people in those schools emphasize moral character. So people who have better moral character are more likely to act better. But there's another school in ethical thinking called consequentialism, that you need to also pay attention to the potential consequences of your actions. And that perhaps should be sort of like the framework to work in, to think about this particular project. You could ask yourself, for instance, right, could we show, if we do need to show this data, if you can reason in favor of showing this data on a map, and then you weigh the fact that this may have potential bad consequences for the individuals that are displayed on the map, you can think this way: well, I need to show this data, but perhaps showing it this way may hurt people, so perhaps I may abstract the data at a different level, and instead of creating a dot map, I can create a choropleth map of concentration of gun owners, because that will make the data more anonymous. You will not be pinpointing people over there. That's the decision-making process. So again, it's not a rule. It's a decision-making process and a dialogue with yourself and a dialogue with other people in order to reach a conclusion, a dialogue that is based on giving each other reasons that are valid for everybody, that you can build that dialogue upon. Now, related to coronavirus, I included this slide over here because Ben was talking about it. Actually improvised this at the very last minute, included this slide because it's related to what you were talking about. So Amanda Makulek from the, who is part of the Data Visualization Society, has these articles about that she published a few days ago, actually a month ago. That time flies by, right? 10 considerations before you create another chart about COVID-19. And she sort of like, this is a decision-making article. It's also about reasons in favor of publishing something versus reasons against publishing something, reasons for why something should exist versus reasons against that same thing existed or putting it out in the open. One of the things that she says is that most of the time, if you're going to create a visualization to visualize something such as coronavirus, perhaps you should do it for yourself just to explore the data, but putting it out, right, you need to have a very good reason to do that. Now, I'm going to recommend tons of books today. Some of you know how much I like to read. So some of the books that have informed my thinking about what you can see the background over here, I can also show you, my desk over here, right? So some of the books that have informed my thinking about all these issues are these ones over here. They are not books about journalism. They are not books about visualization. Again, they are books about ethics and technology, the ethics of the ethics of technology, the ethics of information, right? There are several books here that I think that can be beneficial for anybody who wants to think about these issues deeply. And I'm going to summarize some of these at some point in my own book. Now, the second question is what to visualize, right? So now we have decided that we need to put this out. We need to decide what to visualize and what not to visualize, because obviously we all know that a visualization is a model of reality, right? And the map is not the territory, right? It's the old saying, right? If the map were equivalent to the territory, it will be the territory itself. So whenever we visualize something, we put things in, but we also leave things out, right? So we need to have a good understanding of the data in order to decide what to include, what not to include. Are we including everybody that needs to be included, or every item that needs to be included, or person or whatever, who is being measured, who is not being measured? All these considerations need to be included. So this is an example that appears in How Chat Slides. So a few years ago, one of my best students, Luis Melgar, who is now working for the Wall Street Journal, he was working in his capstone project, and he came to me saying, I want to do a project about homelessness in Florida. How many students are homeless in Florida? And he came to me with a few maps, right? And he showed me a few of these maps. His project is titled A School Without a Roof. It's available online. And he showed me maps that were completely striking. The first time that I saw them, I was completely shocked, because I saw that in some counties in Florida, more than 1 out of 5 students are homeless. K-12 students are homeless. I said, how is this even possible? 1 out of 5, 20% of the students are homeless. I was, oh, wow. And Luis, who is also from Spain, as myself, he said, well, but you need to be careful, because I have not defined what homeless is before you saw the maps, right? So the idea that I had of a homeless person is sort of like is a person who needs to live on the streets for some reasons, right? But that is not the way that homeless is defined by the state of Florida. A homeless student, according to the state of Florida, is simply a student who doesn't have a permanent home. So if a student, for example, her or his fathers are divorced, and then this student needs to move homes 2 or 3 times a year, I don't remember what the threshold is. I think that is 3 times a year, something like that. If that student needs to move 3 times a year or more, then that student doesn't have a permanent home, and automatically that student is considered a homeless student. Now, is this data right or wrong? Well, it's not right or wrong. It's only right or wrong if you understand what it is that is being measured. Once you disclose what it is being measured, then the data is perfectly appropriate. You need to define and disclose what the number, and you need to understand what the data is actually showing and what the data is actually measuring. And then you need to explain to readers. This is also related to the discussion about coronavirus, because many of the graphics that we see nowadays of number of cases, they never disclose that that number of cases is essentially a proxy for tests that have been applied. And that complicates the understanding of, that doesn't mean that the graphics are wrong, but they show what they show, and we need to disclose what it is that it's showing. This will be very relevant. I'm getting ahead of myself when I start talking about annotations in graphics, how important it is to put words onto graphics to explain what the graphics are showing. Now, a much more fun example, and this is also in How Chat Slides, so you can read about it, is this story published by Christopher Ingraham, who now works for the Washington Post, right? Kansas is the porn capital in the United States, according to Pornhub. This is a story from a few years ago, right, in which Chris, who is a great reporter, downloaded data from Pornhub. Apparently, Pornhub publishes every year their data, and you can see who consumes more porn through their website, or less porn, or whatever. They publish this data every year, so you can play with it. So Chris decided to have some fun with it, and he decided to do a scatter plot of porn consumption on the vertical axis, right, number of pages per capita per state of Pornhub, right? And then on the horizontal axis, he put the voting patterns, what the percentage of people who voted for a particular candidate state by state. And as you can see, there is a semi-weak positive association between voting Democratic and porn consumption, right? The more Democratic a state is, the more porn per capita that state tends to consume. And you can see that there's a clear outlier out there, which is Kansas. So that's fun, right? It's like, that's a great headline. We journalists love headlines, right? It's like, Kansas, you're so, I don't know what word to use over here, right? Kinky? I don't know. Anyway, so Kansas, why are you consuming so much porn? Well, Chris discovered later on, and he issued a correction. And let me make an aside. One of the chapters of How Chats Lie has to do with how to identify good sources of information versus bad sources of information. One of the best proxies to identify a good source of information or a reliable journalist is how often that journalist corrects herself or himself. And Chris is very prone to say, I was wrong. I'm going to issue a correction, a very visible one. And he corrected this story because he discovered there was a glitch in the data. Now, there is a reason why Kansas is an outlier over here. And the reason is that, let me explain this. If I am in Florida, now here in Kendall, I'm in South Miami, home, whatever. Let's suppose that here, while I'm talking to you on a separate screen, I type pornhub.com and I watch some porn while I'm talking. Not that I want to do that, right? But if I did that, Pornhub will immediately detect that I am in Florida. It will put a data point. There's one person accessing from Kendall, Florida, blah, blah, blah. This person consumed this number of pages. I will become part of Pornhub's data set, right? That they will release at the end of the year. However, if I used, at least at the time when this data was collected, I don't know whether they have changed these, but at the time, right, when this story was published, if you access Pornhub through a VPN, they will not be able to detect where you are, right? So the way to disclose that in your data set nowadays will be to put an NA. No, we don't know where this person is. But at the time, apparently the data collection process, what it did was that if anyone was impossible to detect the position of that person, what they did was to default the position of that person to the center of the continental United States, which is basically very close to the boundary between Kansas and Nebraska in a completely empty area. And that's the reason why so many people appear to be consuming a lot of porn from Pornhub in Kansas. It was just a glitch in the data. Now, that doesn't mean that the data is wrong per se, right? But you need to adjust for this type of glitch. So you need to know your data really, really well. And if you're going to visualize it, you need to disclose this problem to the people that you're presenting the data to. Now, when I talk about these issues to people who are not very, aware of how to handle data or about statistics or data science, I usually recommend to start reading books about their work as introductions to this field. Unfortunately, nowadays, there's a wealth of books out there that people can consult to deals with issues related to measurement, definitions, inclusion in data. Invisible Women, for example, is a great book about how the numbers that we use tend to mismeasure women versus men, and how men tend to be the default that we use to measure everything, and women tend to be the exception in many cases. Also, a website called We All Count, which deals with issues of equality and equity in data collecting, visualization, and processing. That's a website that was put together by Heather Cross, who is a statistician and also a friend of mine. And recently, Data Feminism by Catherine D'Ignacio and Lauren Klein, which is a book about also equality and inclusion, not necessarily just feminism per se, but all sorts of inclusion, right? All sorts of inclusion in data. So I would recommend that if you have the chance, you take a look at some of these sources. They will expand your thinking. Also, we need to disclose uncertainty. This is just an aside. Some of you know how obsessed I am about the visualization of uncertainty, and I still don't have formed thoughts about how to visualize uncertainty correctly. But if you want to read a little bit about that, by the way, I forgot to mention at the beginning of the presentation that I'm going to share all these slides. So as soon as I finish, I will send you the link to the PDF so you can click on all these resources. So here I have just put a link to to a Dropbox that I put together with tons of articles that deal with the visualization of uncertainty, including one that I wrote a while ago as an overview of the history of the visualization of uncertainty, and a few reflections about why some people visualize uncertainty, some people don't visualize uncertainty, and the many ways that have been proposed to visualize this uncertainty correctly. So what to visualize is also important. What to visualize and what not to visualize is also important. Who to visualize for, right? This is a key issue also nowadays when talking about a coronavirus, right? Should we use a logarithmic scale or not? Well, I would argue, yes, we need to use nonlinear scales. We do, because we need to show, for example, the rate at which the coronavirus is spreading, right? And nonlinear scales may show us how often the number of cases doubles or triples, right? Versus a linear scale. So we need to show that. But the problem is so that's a good reason to use a logarithmic scale, but we also have a good reason not to use logarithmic scales, which is that most people don't know how to read them. So how do you weight them? Well, that's an example of what I mean by who to visualize for and how to weight the different things and how to reach a conclusion. So like something that may satisfy, right, that may sort of like solve this conundrum, these conflicting reasons, right? So what I would say about that is that we know that most people have a hard time understanding even the simplest graphic forms, right? The example that I have in How Chat Slides, that in 2014, the Pew Research Center conducted a study and they discovered that only 63% of Americans, right, could read this graphic correctly, right? And 1/3 of Americans could not read this graphic correctly at the grammatical level. I'm not saying that they could read this graphic very deeply. I'm just saying that 63% of people in the sample could understand that a scatter plot has an x-axis, a y-axis, and each one of the dots represented something, and the position on the x-axis means something, the position on the y-axis means something. This is the grammatical level of the understanding. Now, 2/3 could understand it, 1/3 of people could not understand it. Now, the Pew Research Center at the time read this survey in a negative way. Oh my goodness, 1/3 of people don't know how to read a scatter plot. And I said, when they asked me, what do you think about this, the results of the survey? And I was delighted. I said, this is great news, because, you know, coming from the world of journalism, I know that if I could go back in time 20 years, that percentage, 63% of people who can read a scatter plot at the grammatical level would be much lower, because scatter plots 20 years ago were nowhere to be seen in news media. Therefore, people were not used to seeing them, right? And why was that? Well, because news editors, and this is the text that I have on this slide, right, were trapped in a self-fulfilling prophecy, saying, nobody understands a scatter plot, therefore let's not publish scatter plots. But that's self-fulfilling, because if you never publish a scatter plot and explain it, people will never learn how to read a scatter plot. You need to break that cycle. How? Well, you publish the scatter plot, but you explain how to read it. And this is the key to making many visualizations understandable. You think that a logarithmic scale is the right way to show your data? By all means, use it. If that is the best way that you can think of to show your data, that's a good reason to use that visualization. But you also know that people will not understand it. Therefore, you also have a good reason to provide a good explanation of how to read that graphic. But most of you are familiar with the work of Hans Rosling, right? If you remember Hans Rosling's presentations, particularly the one that he did at for a BBC documentary called The Joy of Stats, if you remember, Rosling puts himself in front of the screen, but the first thing that he does is not to show data. The first thing that he does is to explain how to read his graphic. Here's a y-axis. The y-axis means lifespan. Here's an x-axis. The axis means income. Now I'm going to show you tons of dots. Each one of these dots corresponds to a country. If you are down here, it means that your country is poor and sick. If you're up here, it means that your country is rich and healthy. And now I'm going to show you the world as it was in the past. Let's make the countries appear, right? Now we have, you know, the world in 1810, right? And I'm going to show you countries belonging to Asia, Africa. The color corresponds to the state. The size of the bubble corresponds to the population of each one of these countries. That's explained about. He's explaining the grammar of the graphic before showing the graphic or while showing the graphic. We call these words that could be added to a graphic the annotation layer. And when we publish graphics that are intended to explain something, the graphic alone is usually not enough. You need text. You need a good headline. You need a good intro. You need a good explainer. You need things that point out the interesting cases, the same way that Rosling did, right? Rosling used his own body to show you like the motion of the graphics, to point out different objects, to point out different countries in the display, and so on and so forth. Now, some people in the media are doing these. For example, I have this old example from a magazine that doesn't exist anymore called the Weekly Standard. And this is a graphic created by a guy called David Byler, who is now a columnist at the Washington Post. David used to do data analysis, particularly about elections for the Weekly Standard. And he did tons of charts, very weird charts with scatter plots, with areas surrounded by things to group them and ungroup them and so on and so forth. But he always provided a caption, an explanation of what the graphic meant, how to read the graphic, and then how to understand that graphic correctly, right? Now, another reason to provide written or verbal explanations of the graphics that we do is that, and this, I'm getting ahead of myself here again, that also makes the graphic more accessible. Because if someone is visually impaired, they will not be able to see your visualization, but their computers will be able to read the alternative text that you provide, right? Instead of the visualization, right? That text is machine readable. Therefore, they can still envision the information that you are presenting. And another reason to include explanations is that you may expand people's vocabulary when it comes to talking about visualization. Some of you are probably familiar with Shino Graphics, which is a website by a designer called Martin Lambrecht from Belgium, which collects tons of weird visualization forms, all the innovative ways people come up with to visualize data. So when people try to refrain from using a graphic form, I usually say, you know, if you think that this is the best way to represent your data, this weird graphic is the best way to represent your data and convey the message, by all means, that's a good reason to use it, but always explain it, right? Always explain it. And as I said before, this will be another example related to coronavirus, right? I inserted this slide while you were talking, Ben, right? So the flattening the curve. Well, I foresee that some people will still not be able to understand this graphic. Therefore, you know, I saw this video with Brian Stelter from CNN in which he did the Hans Rosling thing. He put himself in front of the graphic and he showed the animated version of the graphic and he explained the graphic. These curves mean something, these curves mean something. That doesn't only explain the information from that graphic itself, it also expands the visual literacy of the audience that you talk to every single day. And again, it also increases accessibility. And accessibility is something that I'm really interested in also as well. These past few years, I have not formed thoughts about it yet or specific recommendations other than consult, you know, people who are working in this area. This is an article that was published a couple of years ago in Call News Bomber's storytelling with data website, which talks a little bit about accessibility. Okay. Now, another question: how much to visualize, right? How much data should I show? How much data? Well, the thing is that this is one of the most difficult decisions to achieve. It's like what level of aggregation, what level of abstraction, right? Should I show an average or should I show the range? Should I show the shape of the data? Now, the answer to that question is always whatever better tells the story. I mean, some data can be summarized in just one unit of central tendency, but some graphics that would not be enough. You would need to show sort of like the entirety of the distribution. In order, particularly if your distribution is bimodal, for example, just showing the average is absurd. Just because you have two peaks, you need to show the entirety of the distribution, right? So any visualization any data set can be visualized at multiple levels of aggregation or granularity. The level of aggregation or granularity that you choose depends a lot on the nature of the data itself and your understanding of the data and what you want to convey. This example from Howchat's slide illustrates the point. So if you show the US murder rate per 100,000 people using just that, the national murder rate per 100,000 people, if you don't know what lies behind this number, this graphic will lie to you. You may interpret it as saying, you know, but first of all, you probably know this pattern, right? In the 80s and the 70s and the 80s, this number went up very sharply. Then it declined in the 90s. And then in the past 2 or 3 years, I have an updated version in Howchat's slide that extends this line. In the past few years, there has been an uptick in the murder rate in the United States. It is very easy. If you don't know what lies behind this data, it is very easy to say, the United States is becoming a more dangerous country. And that is not true. That is what the graphic conveys if you don't know more about the data or if you don't disclose certain peculiarities about the data. And the peculiarity is that if we could plot every single place in the United States, every single town, every single city in the United States, most places in the United States will be around the national average, a little bit above the national average, or most of them will be below the national average. Because in general, the United States is a pretty safe place, right? Most places are pretty safe. There are barely any murders. It's very safe. Now, the challenge, though, is that this is a very skewed distribution because there are also certain cities, certain towns, certain neighborhoods in certain cities in which the murder rate has increased so much in the past 3 or 4 years that they sort of like skew the national rate. There is a New York Times article that in which the reporter talked to several public health experts and criminologists and statisticians who deal with crime data every day, who explain this phenomenon, that if you only show the national rate alone, only that, you are not informing people, you are misinforming people. You need to disclose the rest of the things. You need to show the distribution, or if you cannot show the distribution because you only have access to the national rate, you at least need to talk about it. You can show it and then say, well, but this uptick here is due to just these specific places. Don't read these as the United States is becoming more dangerous, because that is actually not true. That's not what the data, that's not what the graphic is conveying. Question number 5 is how to visualize it. So I'm going to move through this one really quickly, just because I guess that most of you do visualization for a living. So this has to do with choices about, for example, encodings, right? Should I use a bar graph, a line chart, height, length, position, color, etc.? What we need to remember is that visualization is always purpose-driven. We need to always think about what the purpose of the visualization is, and according to that, that gives us reasons to choose one graphic form or another graphic form. The purpose is a fact that can give us reasons to make one decision. So years ago, I did a workshop for the European Union, for the European Court of Auditors, in Luxembourg. And whenever I do work for clients, I always ask them to send me examples of their work. And this is one of the graphics that they sent me, right? Your pie chart, the variant of the pie chart called a donut chart, right? A donut chart that is showing of all the migrants who arrived to Greece. Sorry, I'm going to turn the light on because it's getting a little bit dark. Of all the migrants who arrived to Greece in 2016, where they came from, what percentages came from different countries. So you can see that half of them come from Syria, around 1/4 from Afghanistan, and so on and so forth. And when clients send me this stuff, they usually ask, do you think that this is a good graphic or a bad graphic? And my answer, as long as I don't think about rules, I like to think more in terms of like paths, reasoning, dialogue, is to always say that no graphic is ever good or bad in the abstract. Graphics are better or worse depending on the purpose that they have, depending on what they want to convey. And the way that I framed the conversation was to say, well, let's imagine, let me just think out loud. If your purpose with this visualization is to show that half of the migrants came from Syria and the other half came from other countries, therefore you want to emphasize Syria versus the block of all the other countries, I don't have anything against this visualization. The only thing that I would recommend will be to sort of like change the colors to emphasize that message even more, to use blue for Syria and gray for all the other countries, just to emphasize the half versus half message even further. But what about if the purpose of the visualization is not to show half and half? What about if the purpose of the visualization is to be able to compare these countries to each other? Then the pie chart is not the right solution, because we know that the human brain is not very good at comparing angles, at comparing areas. We are much good at comparing just a single magnitude, such as length or height. Therefore, perhaps a bar graph in which we can rank the countries and then compare them may be better. And what about if, the purpose of this graphic was to show the relative position of these countries in relationship to Greece? Then you probably need a map. Well, according to this conversation, we could have multiple ways to represent this data: through a map, through a pie chart that uses angle and area, through a bar chart that uses length or height. None of these graphics is good or bad according to the rules. They are all better or worse in relationship to the purpose that you have in mind whenever you are going to design it. And the reason why I emphasize this so much is that, I don't know if you have experienced this, if any of you teaches, but one of the experiences that I have with my own students is that I know for certain that if I give a group of beginners, of students at the very beginning of the semester, a data set in which everything adds up to 100%, and I tell them, design a visualization with these, the immediate visualization that they will design will be a pie chart. And if I give them a data set that contains a geographic variable, such as countries or counties or states or whatever, I know that automatically what they will click on in Tableau or in Excel or whatever tool that they are using will be a map. They will create a map. And when they bring the exercise, I always ask them for reasons. Why is this a map? And they say, well, because it has a geographical feature or geographical variable. That's not a good reason. The reason is the purpose of the visualization. Is the purpose of the visualization to show geographic patterns in the data? Then a map is the right solution. But what about if the purpose of the visualization is to be able to compare countries to each other? Then the map is not the right solution. The purpose gives you a reason to shape your data in one way or another way. I guess that most of you are familiar with resources such as the Data Visualization Catalog or the Financial Times's visual vocabulary posters. These are all great starting points to have these sorts of discussions as to whether we should represent the data in one way or in another way. But there are many other resources. So for example, probably many of you are not familiar with this other one. This is a website in which a group of researchers in visualization, coming mostly from the world of computer science, but not only, they translate visualization research. They get tons of papers, right, that have been written about visualization, and then experiments and so on and so forth, and they try to translate the results of these papers and these experiments into a language that someone like myself can understand. So I would greatly recommend that you visit these websites. And then consult books, obviously, right? For Fundamentals of Data Visualization, for example, by Klaus Wilkie. This is one of the best books about visualization that I have read in the past few years. It's a great book. And one of the advantages that it has is that its draft is completely available online for free. So you can consult it if you don't want to spend more money in books. But then there are many others. I put the Truthful Art in there just because I also deal with these issues, or Cold Storytelling with Data, which is a great primer, elementary, simple, straight to the point, short, concise, direct to the point book, just to get started for beginners. What visual style to use? This is something also important. Again, remember that I'm not talking about dashboards. I'm not talking about analytics. I'm not talking about exploratory visualization. I'm talking about communication, visualization for communication, the kinds of things that we see in the media every day. Well, style is also important. What style should we use, right? I usually say, and this will probably end up in the book itself, that most of the time, what we want to design is bread and butter, meat and potatoes visualizations, right? The traditional graphic forms, bar graphs, line charts, scatter plots, and so on and so forth. These are graphics from the Congressional Budget Office. These are graphics from the Pew Research Center, very traditional, conventional, following the rules, and so on and so forth. But sometimes we may want to break the rules. We may want to have a good reason to break the rules and do something a little bit more unique, a little bit more attractive, just because we want to attract people to the data, right? For example, one of my friends, his name is Jaime Serra. So Jaime is a Spanish data visualization designer and also an artist. One day he decided that he wanted to visualize how much coffee he drinks a year, right? And rather than doing, if I had to do that myself, I'm not a particularly creative person. The way that I would do it would be every day, right? I would try to drink the coffee every morning in the same mug. I will draw some sort of a scale over here. So whenever I pour coffee, I will measure the number of ounces, right, in my coffee mug, and then I will record that in a spreadsheet. And then at the end of the year, I will have 365 records, and I will plot that as a time series line chart to see patterns, right, ups and downs in coffee consumption. But Jaime decided to do something a little bit more fun than that and a little bit more attractive than that. He decided to visualize the data this way. He got 12 pieces of paper, tabloid size, if I remember well, and then he folded them in a way that the papers were subdivided into quadrants in order to create like the calendar for a month, right? And then every day when he drank coffee, he poured the coffee in his mug or in his cup. He shook the mug a little bit in order to spill a little bit of coffee on the sides in a way that the coffee trickled down to the bottom of the cup and accumulated at the bottom of the cup. And then he positioned the cup of coffee on top of the quadrant that corresponded to that specific day, leaving a stain on the paper. And at the end of the year, he had a physical visualization of coffee drinking, right? How wonderful is that, right? This is not analytical, obviously, but you can still see patterns, right? You can still see when Jaime was drinking a lot of coffee in the middle of the year. Probably he was working a lot and being stressed out, etc. You can sort of like start seeing when he was not drinking coffee at all, probably on vacation, weeks off, etc., right? So you can still see these, right? So there's a space for these types of visualizations, even in companies, right? Whenever I talk to clients, corporate clients, I usually and show this graphic, they say, well, but we will never use a graphic like this. And I say, no, that's not true. You publish reports every year, right? With your results, etc. Now, what you put inside on the inside pages of these reports is the bread and butter graphics, line charts, bar graphs, and maps, and things like that. That's great. Put that in the inside pages. What do you put on the cover of the report? You put these, because this is what will attract people. What is this about? It's a piece of art at the same time that is also a piece of data visualization, right? Now, let me jump one of the slides over here, because I want to be brief. Now, what words to add? That will be the last point that I would like to make. So going full circle to, well, actually, let me go back to this slide. I wouldn't want to show it, but this is another fun example of untraditional data visualization. This is from Reuters Graphics. They decided to visualize, how much bottles, plastic bottles, are consumed in the world in a minute, in an hour, in a day, in a year, and in 10 years, right? And the first thing that you see is like this sort of like, a deluge or like rain of bottles of water coming over a truck, right? And you have a counter over here. So this will basically count the number of plastic bottles that are bought, that are consumed all over the world in 1 minute, in the first minute that you spent watching this visualization. So again, this is not particularly precise for analytical purposes, but the impact that it has on the reader is like, it's shocking. Say, oh my goodness, I never imagined that it was so much plastic being consumed, right? So when you combine this approach, sort of like the punch in the gut visualization, with the traditional graphic ones that we have, you have the best of both worlds. You begin with the sort of like the shocking, eye-catching, powerful visualization that gives you an idea of scope. And then you go to the analytical part of the story, in which you use line charts and bar graphs and so on and so forth. I'm not going to, oh, there you go. It's 1 million of bottles per minute or every minute. And then they visualize the data also every hour. So this is the Christ the Redeemer statue in Rio de Janeiro. This is in every day, the Eiffel Tower, and this is the mountain of bottles of water. And I'm going to leave it there. If you want to see the other graphics, you can just navigate this project on your own later on. And then going full, oh, actually I had an animation here. I didn't even realize that. Anyway, so going full circle again, what I explained before about the annotation layer, I feel very strongly that one of the most overlooked features but in books about data visualization, including my own, is how little attention we pay to the words that we put in our graphics. And I wish to sort of like work on this a little bit more in the coming year and perhaps write something meaningful in the next book. So going to the Financial Times, you mentioned before John Byrne Murdoch from the Financial Times. So there was an interview a while ago with John Byrne Murdoch from the Financial Times before coronavirus, way before coronavirus, in which he said that the most important thing that the data team does, the Financial Times does, is not the graphics themselves, it's the explanatory layer that they put on top of that. So they do visualize the data, but then they try to put it in context somehow. Now, the idea of an annotation layer, or even the term annotation layer, that's not John's authorship. It comes from Amanda Cox from the New York Times. She's a statistician, and she came up with apparently with this term of the annotation layer, which is incredibly important in my opinion, because in visualization for communication, again, what matters is not the visualization itself, is the visualization plus the words, either written or spoken, that you pair with the visualization. So I usually say that explanatory visualization isn't just about visualization alone. It's about helping people understand data. The way that you do that, the means that you use to achieve this goal, don't really matter that much. The visualization, the words, the combination of both, if you give weight more to one thing or to the other thing, that doesn't matter that much as long as you achieve that goal, which is communicating an idea or a message or helping people conduct better lives, which is the ethical purpose of any visualization, in my opinion. Anyway, so that's all that I have for today. I already exported the slides to Dropbox. So while we chat here, I will share them with everybody, and I have time for questions. So just let me know.
Alberto, that was great. Thank you very much for that whole presentation. That was awesome. We have a few questions people have chatted to me, but if you have questions, please post them in the chat and I'll go through that. But my first question is about the something you mentioned earlier. And first of all, you solved the mystery of the Kansas data for me, because some people know this. I sell a game online, and like I keep track of the IP addresses of people who bought them. And like for whatever reason, I thought I was huge in Wichita or something, but evidently not. That's just like a proxy.
It may be a glitch in the data, right? We never know. Yeah.
So so you mentioned about the gun map, okay, and that was public data. And as a visualization expert, how responsible are you at merely making access to that data easier?
That's a key question. It's like something that I'm going to try to write. Let me make an aside, by the way. I usually write books to help me think better about things. So I usually write because I want to think about something. I wrote The Truthful Art just because I wanted to learn more about statistics and think deeply about statistics. And I want to write this other book along with Alisa because I want to think about all these very complex issues. I think that that's the key question. The problem is not that data is publicly available. It is. This is public data. You can FOIA request it and you may get it, right? So that the data is publicly available. But I think that there is a key ethical difference between the different ways in which you can present the data. When you present the data in a table, that creates a sort of like a wall of abstraction between you, the reader, and the data. When you represent it as a map, you sort of make the data more tangible, right? You sort of like see it, you can touch it, you can zoom in. That's different, right? You facilitate that process, and there are ethical implications in that sense. And the way, as I said before, the level of abstraction that you apply to represent the data also matters. Do you need to show every single data point? Well, no, perhaps you can just abstract the data and aggregate it and just use rates, for example, and just then use a choropleth map. I just share, by the way, the slides in the chat window. That link will take you to the PDF. And also for those of you who are planning to read How Chats Lie or already have a copy, I am also going to link here to the clarifications page and also the downloadable graphics. Just 1 second. Because most of the graphics that appear in How Chats Lie can be downloaded for free, and you can download it through this link over here. So great question. Thank you. Thank you again.
Yeah, no problem. And so we have another question from Bruce. He said, it was talking about that murder rate graph, the homicide rate. So how would you display this data to compensate for cities that skew the average, and what things should we consider when solving issues like that?
Yeah. So yeah, I don't have access to the entirety of the data set, right? No, I didn't have access to the data set when I wrote the book, but I explained that, again, as I said in the talk, it's like, I will still show the data. That data is the data. It's like the national rate. But I will try to sort of like mention that, saying, you know, take a look at this point, this uptick over here. This is not because the entirety of this is becoming more dangerous. It's because there are certain things that I will try to explain the idea of a skewed distribution, right? What that does mean, right? So the same way that the Washington Post created this abstract visualization to spread, to explain the spread of a virus, that is not really a visualization that is based on actual data, right? It's sort of like an explanation of how something works, right? We could do the same way in these types of stories to explain the notion of a skewed distribution. This is not that all places are close to the average, so to speak, the national rate, right? We have a huge spread. Some cities have huge murder rates. Some cities have most places have very small murder rates. You can sort of explain that. And if you explain that, again, you are accomplishing two different goals. You are not just talking about that particular story. You are also helping people expand their minds and learn something new that will prepare them later to be exposed to stories like that in the future and be a little bit more skeptical when they see an average. They say, well, but you know, this average, this mean that you're showing me here, what is the underlying distribution? I want more people to be able to pose that type of question rather than taking numbers at face value all the time, right? But again, if you have access to the data itself, then I would plot the sort of like I will show the national rate, but then I will show the mass of dots if it were possible, just to explain that feature.
Great. We have another question here. This is from CJ. He says, what is the most egregious or most dangerous data visualization offense that you've seen lately in the era of misinformation? And I've seen some of these in your last talk that you gave on visual trumpery, but
yeah.
Let's hear your favorite one.
Not necessarily data visualizations per se, but some of the early days hot takes about how coronavirus was going to spread, written by particularly technology types from Silicon Valley, applying mathematical models and forecasts to data that they know little about. I think that was completely irresponsible. Actually, I was a little bit perhaps aggressive a month ago against those types of articles that appear randomly, saying this is noise, right? It could be right, it could be wrong, but whenever I see an article written by an engineer, a data engineer from Google or Facebook or whatever, you know, blindly applying a mathematical model to epidemiological data that he doesn't understand, It could, again, he could be right or he could be wrong, but the safest thing as a reader to do is just to ignore it, because it's much more likely that it is wrong, just because that person doesn't have any sort of expertise with that type of data. If you, so as Amanda said in her article about being responsible with visualization, perhaps I have a bias against doing that, just because I know how easy it is to screw up when you don't know the data really, really well. And I always bias on the side of safety and, perhaps care and, caution. And if I don't see a wide variety of epidemiologists and virologists and public health experts, etc., quoted in a story supporting the points of that story, my impulse is to say, I'm just going to ignore this. I'm going to move on and take a look at other sources, because there's so much if there were few sources to consult, then we will need to read everything just to sort of like create an idea of what is going on. But there are so many sources nowadays that we can sort of like weight them, right? So I would say that that's the most dangerous, sort of an irresponsible thing that I have seen recently. But then on the safer side of things, the example that opens how chess lies is still one of my favorite examples. The way that Trump keeps misusing the county level 2016 presidential results map, and he uses that to argue for everything against impeachment. And this is my popular support. Well, no, that doesn't really show popular support. It's like it shows something else. It shows who won where. That map is not necessarily wrong. It's only that you're misreading it and you're misusing it. And that's the case with most graphics that I have in the book. It's like they are not really graphics that are badly designed. They are graphics that are correctly designed, but they are used to argue for the wrong, to make the wrong arguments, right? To support the wrong arguments. Yeah. No, it's not. Someone sent me a message. It's county level. It's county level vote. The example that opens the book is county level, not state level.
Great. Well, if anyone has any other questions, it looks like Herb sent one in. Can you give a good example of how to use a pie chart?
I just did. The one that I showed. I don't have anything against that particular pie chart. If it emphasizes a half versus another half, for example, even if the second half is subdivided, right? If it is de-emphasized to emphasize one of the halves, just to make that point, right? That's a perfect, in my opinion, it's a perfectly acceptable case to use a pie chart. I don't have anything against it. So again, my opinions have evolved quite a lot throughout the years just by observing how people read these graphics. And they can really extract meaning from that graphic. They can see the message quite clearly. Therefore, why not using a pie chart? Now, the myth that pie charts are evil is one of the examples of what happens when something that a person says becomes sort of like, let's say, a rule that is set in stone, or like conventional knowledge, right? This all began probably with either Brinton or Tufte saying, pie charts are evil, don't use pie charts. And people approach that uncritically. It's like you say, this person says something, this person is an expert, let's not do it. Well, I trust experts, right? If someone like that says that, I will tend to say, well, let me look into it, right? Why is this person saying that? What are the reasons that this person is providing to argue for that? And I always encourage people not to read my books like that. I am just a dumb journalist. So whatever I say in my books, take everything with a grain of salt. Try to understand what I come from, right? Because I always try to explain where I come from to provide a reason to do something. Again, this is all related to what I'm planning to write about in the future. It's like opinions need to change in the face of evidence, need to change in the face of changing conventions, right? The way that we design visualization today is not the same way that we designed visualization 100 years ago. Conventions have evolved. What is acceptable and not acceptable has also evolved. And we need to be aware of the historical moment that we are in. And our opinions about what is acceptable or not, or what's appropriate or not, will also evolve with time. The same way that writing has evolved. We don't write today the same way that we wrote 100 years ago. Why should visualization be different, right?
Okay, Alberto, but what about 3D pie charts? Those are evil, right?
No, that's, yeah, those, yeah, I don't like 3D in graphs, but I have good reasons to argue why not, right? They distort it. As you put a chart in 3D, a pie chart in 3D, that emphasizes the segments that are closer to you, and particularly if it is in perspective, and it distorts the things that are farther away from you. But even in that, they are sort of like gradients of evil, right? So a pie chart that has only a slight tilt right, is better than a graphic that looks like that. So as I said before, I tend not to see anything, or I would say better, I have trained myself not to see everything in black and white, good or bad. I always try to use the language better or worse, right?
Great. And so we have one more question. This is from Fernanda asking, what can you recommend to students who want to begin a career path in this area?
Read books that have nothing to do with visualization. That's the first thing. So yeah, you do read about visualization, that's for sure. But expand your mind, read about things that you care about. If you like reading about economy, go for it. Read about economics. If you like politics, read about politics. Read nonfiction. In as much as you can, establish a discipline of reading at least one book a week, I would say, at least one serious nonfiction book a week. Read with a pen next to you and write on the book. Take annotations, take notes about the book, because that's the only way that you will remember. I don't have any book right now here that, well, yeah, I have several books here, but none of them is annotated because these are books that are still waiting to be read. But write on the margins of the book, write notes, because human memory is really, really weak. That's the first thing. Then on top of that, learn about visualization, obviously. So learn about how different authors, schools, different approaches of visualization, learn a little bit about visual perception. I didn't mention before, Colin Ware's information visualization book. That's a great introduction to perception for visualization, great intro. So read things like that, and then practice. So choose one or two tools. It doesn't really matter which ones. You will find tons of people that will say, Tableau is great, just go for Tableau. Some people will say, don't use R, use Python, because Python is a general purpose language. That's bullshit. R is great. Use R or use Python. It doesn't really matter. Whatever gets the job done. Just choose a tool that suits you well, right? I tend to believe that there's something genetic about preferences. For example, I have a natural allergy towards JavaScript. I hate JavaScript. I hate D3, but that doesn't mean that D3 is bad, right? It just means that it doesn't suit me. And even if I try several times to get into it, and I always hit a wall. Perhaps one day I will be able to break that wall and I will stop hating JavaScript. And I tend to prefer R over Python, but that's just because perhaps I got into the R community, right? Before I got into Python, whatever. It's like, but that doesn't really matter. What matters is that you choose 1, 2, 3 tools, you get really good at them, and then you are able to produce almost anything on those tools. Keep an open mind, obviously, and keep learning. Always keep learning. And then practice, 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 practice. And take critiques, particularly unrequested critiques, with an open mind. It is very hard as a human being to see your work criticized. And some people can be really nasty when criticizing somebody else's work. So I would, if you want to criticize someone, try not to be an asshole, right? But when someone gives you critique, even if it is tough critique, right? Tough critique, right? Try to take it, try to learn where that person comes from. The other day, for example, I tweeted about what I would call my toughest critic ever. This was a person who wrote an extremely critical review of my first book. That hurt. It hurt a lot, deeply, right? But I looked into it a couple of times. I came back to it after I really got angry. I calmed myself. I went back to the critique, and I noticed that he had a point. I disagreed with some things that he said, but I did agree with some things that he said and critiqued in there. So I came back to him and sent him a letter saying, I agree with you in these things, but I think that you are wrong on these other things, right? I appreciate that. I would appreciate that you have adopted a less assholey tone, right? But I will take your critique, right? Well, we became virtual friends. I sent him a copy of How Chats Lie right after, a signed copy or whatever. It's like, befriend your critics, right? Encouraging them not to stop being critic, because once you establish a friendship with someone, it is very easy to stop being critical towards that other person, because you will fear hurting that other people's feelings. So try to be an honest critic of other people's work, and try to be honest with that other people who offer you sometimes, unrequested critique, because sometimes people are well-intentioned. They say, well, I think that your graphic doesn't work that well because of this reason or that other reason. Assume that people have good intentions. Most of us have good intentions. There are bad actors out there, obviously, evil people, but I am an optimist. I think that most people have good intentions, and particularly the visualization community. The visualization community is very flat, is very horizontal, particularly recently. Everybody talks to each other, either online or in person. We need to take advantage of that, and we need to preserve the nature of this community and keep it horizontal rather than vertical and hierarchical. I went way beyond the answer to your question, but I hope that it is helpful.
No, that was great. That was an excellent answer to the question and all the questions. Thank you again, Alberto, for coming to the Philadelphia Data Visualization Meetup. Thank you everyone else for coming. We had I think 70 some people in the Zoom at some point. Please definitely check out Alberto's book, How Charts Lie, and any of his other books too, because the other books are good, despite what that guy was saying. And also thanks to Crossbeam for sponsoring the meetup. And I hope to see you all again in person when this is all over. And thanks for coming.
Thank you. Thank you, everyone.